what I want to do today is I want to talk about some of these techniques in green building, and I'm going to start off with advanced framing. So let's talk about conventional framing versus advanced framing a little bit to kind of bring you up. Okay, so let's talk about framing. And so to understand the framing that we do today versus traditional framing, you know, in the old days, and I keep saying about the old days, and the old days to me were not all that far gone. And I mean, it's still, a lot of these are still practiced today. They don't change anything. And I'm not seeing what I'm wanting, so I'm just going to go over here to the whiteboard and start drawing. So let's look down on a corner. Corners were always problematic. And let me give you an example of that. Look at this corner right here. So this is the corner of the house. And this is the corner. And you see this cold spot here. All right, you can see every piece of frame in here. But then we've got this really cold spot. And notice that this whole corner is colder than the rest of the studs. All right, so it's a darker color. So what's going on here is when we built these, we have, so let's get our terminology here. And so this is called a through wall, meaning that the plate goes all the way to the outside. And then we have a butt wall, which butts into the through wall. So we have to attach these two walls together somehow or another. So we would basically take a whole bunch of 2x and shove them together to end up with, so okay, so when I show an X, that means it's a full stud. When I show a diagonal line, that means it's blocking. So if I were to look at this from the side, I've got 2 pieces of wood that run all the way, and then I have blocking on the middle part. Okay, so this is open, and this is open. So then we would, you know, we've got something and actually did that the wrong way. Change that. All right, so in the very beginning, people started shoving these two together. And so what is this dimension here? What is 3 times 1.5?
4.5.
Okay. So actually I've drawn this wrong. This should be out here a little bit. Okay. And then when we go to put our butt wall on, then there is a stud that we start with so that we can nail directly into this big massive mess here. Now, what difference does that make? Well, we have a lot of wood here, and we have open cavities in here. So the framers, they're doing their best. They're trying to build this house. So we've got, you know, we get the footings, we get the foundation walls, we get the floor, we get the walls, and then we get the roof. And that way we can kind of slow down a little bit and come back and do some stuff. Okay, we've got it protected. It's called, you know, getting it under the roof. And so then we can come back and take our time to make it better. So it's a rush. We're in a rush to get this roof on. So in the process, we put our plywood sheathing on here, and we've closed up this spot here. So then the insulation company comes in and they start putting in insulation in the cavities. This little cavity here is covered on the outside and cannot be got to. That was terrible English, cannot be got to. So this is a huge open gap here in this wall. Okay, so now it's summertime, and the old sun is beating on this wall here like crazy, and we have, remember the three types of heat transfer. We have radiation, and that's what this here is. The sun's beating on this corner by radiation. And this heat is going to transfer through all of these materials into the house by means of conduction. Okay, so it gets this hot, which gets this hot, which gets this hot, and then escapes into the room. And we have hot and cold corners. Because we don't have any insulation in here, it's an easy transfer of heat through here. And this is problematic. Okay, this is huge, huge problems. I'm going to erase this and leave that one in place, and let's draw a new one. So there's many different ways that we can improve on our framing. So we can use less lumber, and to go back, this here gets even more complicated if we use a 2x6 rather than a 2x4, because on a 2x6 it's 5.5 inches from here to here rather than 3.5 inches. So a lot of times you would see people putting pieces of plywood in here to increase this space out. And, you know, so that we can put our drywall on this side here, you know. So, all right, so we have, let me go back, and we got 3.5 here. We said that this was 4.5 here, meaning that we have 1 inch of space. And if I'm getting anybody confused, please tell me. I have 1 inch of space between the edge of this stud and the edge of this stud. So if I were to put this piece of drywall on first, which is 1/2 inch, then I have only 1/2 inch of space here to nail this piece on, which is problematic. So people would put plywood in here to increase this out so that I didn't have to worry about which piece of drywall to put on first.
If you did it that way, you'd have 1 inch.
What's that?
If you put the one on the left first, you'd have a whole inch. Then when you butt the other drywall, you'd still have 3/4. No, you'd have an whole inch either way.
No, 1 inch take away 1/2 is 1/2.
No, I'm saying if you put the one you've drawn vertically in there first, you've got the whole inch.
Yeah. But that's thinking. You got to think. You got, you know, the drywall people, I promise you, drywall hangers don't think.
Oh, well, yeah.
I mean, they are thinking, let's get this up, hurry. We don't give a flip. And to be honest with you, I have seen more drywall hanging people that have no concept of construction whatsoever. They're college students. It's, you know, it's a no-brainer, and they don't think. If you know, now, you know, the more professional companies, yes, but they're, you know, professional companies, you look up drywall hangers or drywall companies, you're not going to find as many drywall companies as you would plumbers or masons or something like that. Because, like I say, now finisher is a different thing. It takes a skill to do finishing, good drywall finishing, but it doesn't take a whole lot of skill to hang drywall. And so everybody and their brother is, you know, can do it, you know, but they can't do it right, and they're not going to think about it. So anyway, by putting this piece of plywood in there, then they increase this size out, and they've got a whole, you know, 1.5 inches in here, and they don't have to worry about this. Again, this is pre-thinking ahead of time And that doesn't always happen. A lot of times it was just slamming a couple pieces of wood together and moving along. But as we have come into the new age of green building, then, you know, thinking comes into play, and we think, wait a minute, how can we improve this? How can we do this better? So over the years, we have come out, we've you know, become aware of such things, and we're trying to do better. Where was that one? I see, there we go. So we end up with better types of framing methods. So here's that conventional corner, and it had that big gap in here. This was a block of wood, all right? Here is the new outside corner, a 3-stud California. I don't know, everything these days is a California. You got a California bed, a California king, you got a California hammer, you got a California corner. I don't know. Anyway, so this is, you know, the new way of doing this. Well, what if we built it like this? Drywall clip to hold drywall in place. I have been in the building industry since I was 12 years old, and I have yet to have one of these plywood clips in my hand. I can show you a picture of it, but they're not used very often. So there gives you 2 different types right there. So it's just a corner, you know, and it's a metal piece. So you have to use a different screw to go into this metal. So in commercial buildings, all of the framing is done with metal studs. And so the people that do the drywall in commercial framing they have different methods. They know how the metal works. They can screw into it, bam, 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 not a problem. And it's good. But if you get a residential hanger that goes into the metal industry, he's going to have a hard time. There's going to be kind of a learning curve going on there, so that he gets the feel of going into metal. So what I'm trying to say is, when you're screwing into wood, you hit the wood, it goes in. Okay, there's very little resistance on it. But when you go into metal, you have a little bit of resistance because it's metal, and then it pops through. And like I say, you use a different type of screw in there that is very super sharp and will penetrate that. A lot of times they have smaller threads on them, because if you took a wood screw and put it into that metal, once it grabs that metal, it goes so darn fast, it probably just sink through completely into the drywall. So, you know, drywall seems to be the thing that drives a lot of our building, because it's easy to put into place. Before it was, you know, we had plaster and stuff. So we've got this through wall, we've got the through wall here that we end up putting, you know, just 2 studs in. And then we have the butt wall that comes in that has its own stud. And that way we can get in behind it and put insulation in it. So now we have this little area here that's a thermal bypass. Before we had a larger area that was a thermal bypass. By doing this method down here, we're moving this piece of wood to the outside. All right, so before we had it to the inside, and now we've got it to the outside, which gets this away. We have less thermal bridging. We had all of this area here as a thermal bypass. On the outside corner, we have this area as a thermal bypass. But down here, because we've moved this piece to the outside, it actually helps with 2 things. One thing, you know, if we were to frame in here and we were to start with, say, a trim piece, then when we go to put our siding on, we have nothing here to nail to. Over here, when we put our trim piece on, we have something to nail our siding to. But over here, we don't. By doing this method, we put our trim piece on, then we still have something to nail our siding into on both sides. And now we have a very small area and a longer travel, which is also in a 90-degree. So, you know, we have a small area here that's going to transfer heat from here to there, and then a small run through here. So a lot of this may be lost, but we're going to, you know, this area here is where we're going to have the radiation hitting and transferring that heat indoors. So it's a much smaller area there by using this metal clip on there. Again, in all of the years that I've been in construction, I have yet to hold one in my hand, and I have yet to be in a house and see one used, period. The Lowe's here in Morgan don't even sell them. I've asked them several times. They can order them, but they don't sell them. So that kind of gives you an idea about that. So let's talk about the T. All right, so what is a T? A T is just that. We have the exterior wall, and we have an interior wall that is intersecting this. So in the past, we come to this and we build these T's before we put them in the wall. So a rainy day would be spent building T's and corners and having them ready. All right, so this is all full studs, and you know, then you've got your own center spacing going through here, and a lot of times that would be 16 inches on center, which was the common. We go to put our sheathing on. Bam, we have just closed this hole here, and there's no insulation. Insulation people come in here and they put the insulation here. And then this, there's no insulation in it. So we have we have cold air that could infiltrate this, which means that we have a suction of cold air that's wanting, you know, that's trying to pull warm air. Remember that warm air goes to cold air, and it's, you know, it's like a big old suction. It just sucks the life out of us. If we've got air conditioning going on in here, the opposite effect is going to happen. So how can we improve on this? So by doing a ladder type, there's a couple of different ways that you could do this. Actually, one way, if we're using a 2x4 wall on the inside, so we've got our own center spacing studs through here, and they don't matter where they go. We can take a larger 2x, so this is a 2x4 wall, and we can put a 2x6 in here sideways that's attached top and bottom, and then we have something that we can attach our stud for our intersecting wall here, and then we still have room that we can put drywall to it, and we can insulate all the way through it. And I'm running out of time, so I'm trying to rush through this, and I'll come back and talk about it a little bit more. I'm going to have to come back and talk about it a little bit more on Wednesday. So the other way is doing a ladder. So we have our own center stud spacing, and we do a ladder. And so when I say that, this is what I mean by a ladder. We're putting in these little bridges here so that we have something to attach the stud to. Therefore, we can get in there and put our insulation in behind that. All right, so let's recap what we were talking about the other day. We're looking down on a stud wall. We have, and Eli's trying to call me in the middle of the thing. Let me just answer this right quick. Hey, buddy, I'm in the middle of a class. Let me call you back. Everything okay?
Mom told me to ask you about the internet.
Oh, it just was freezing. So I don't know. Maybe because I'm on Zoom.
So is it still freezing?
I don't know. I'm on Zoom now.
But it's not freezing on Zoom?
No.
Okay, then. Yeah,
Okay.
fine.
All right. See you. Bye. So we're looking down on this, and you know, conventionally, we would have a stud, we would have a spacer, we would have another stud on here, and then you know we have the the stud in the butt wall. And then we've got just this little bit of area right here that would be used to put a drywall on. We got to make sure that we put this piece on before we put this piece on. So, you know, this is old school. What we want to do nowadays is we want to do a California corner. An energy efficient corner basically is what we're trying to accomplish there. And so, wait a minute, sorry, bam. Make sure I get this right. Well, for some reason, I'm lost my mind here a second. Let me look at it. Jeez. Of course, I don't have it. There it is. So yeah, I'll just show you that picture. So here is the energy efficient corner that we have on there. And, you know, doing it in this fashion here, then if we try to put our siding on and we don't have plywood on this corner, then we have nothing to nail our siding to at this point here, because we've got our trim boards on there. So we've got to really pay close attention to that and make sure that we have something here to put that on there. The other day we got into the T's in old school. We have the through wall, we've got the intersecting wall. We would have a stud in here that's going to be on the intersecting wall. And, you know, just as, like I say, old school, then we would have this T in there. And this one here could be a full stud, or it could be blocking. Most of the time it was a full stud. You know, back in the 50s, 60s, 70s, 80s, into the 90s, even when we started, I mean, you know, studs were 75 cents, 80 cents a piece. And so that's something, let me put that in there where you can look at this. So when I started business, I was paying 80 cents for a stud. All right. Today, the last time I looked, they were $7.48 a piece. Now that's a stud. So that is a 2x4 by 93 inches. All right. So it's pre-cut for a single bottom plate and a double top plate. So when we look at that, we have a double top plate, we have a single sole plate, and then that stud is cut at 93 inches. So we have a total from floor to top of plate of 8 foot 1.5 inches. And that way we can, you know, we've got some room to put our gyp board on, and 1/2 inch on the ceiling. And, you know, we've got an 8 foot, or we've got basically 2 4-foot pieces that would go on in this fashion. Generally they're laid down, and that gives us a total of 8 feet there, which if you do all the calculations, then you end up with a little space down here at the bottom that you know, is open to the bottom of the stud. But then if you put a 3/4 inch hardwood floor on it, then that leaves you with about a quarter when you're all said and done there.
Or carpet.
Or carpet. Yeah, if you put carpet on it, then you've got a lot more space down here. You've got about an inch there. So you know, this is a bad idea because, you know, they put that sheathing on, and then this space here, we can't get insulation into it. So so what we want to do is do one of two ways that that can be done. Got the intersecting wall in here, and we're going to say that this intersecting wall is a 2x4 wall. Oops, sorry. 2x4 wall. Then we could put a 2x6 here going all the way up, and then that way we can shove insulation in between our studs and get that insulated very good even after the sheathing is going on. Or we can do the ladder type, which means that wherever this stud lands and wherever this stud lands, Then we run a ladder up through there. I think I got a picture of that somewhere. Or not. I could have swore I had that. There's that corner that I was telling you about, 2-stud corner, insulated corner. There's the ladder. That's why I knew there was.
Oh,
So
yeah.
see how the ladder goes in there. And generally, you know, I don't know, you know, different people do it different ways, but I always,
The ladder'd be cheaper, wouldn't it?
I don't know, well, probably because it's a, you know, it's made out of 2x4 material, but it all depends on what this distance is. Are you going to need 1 or 2 studs? I mean, you know, 1 2x6 down through here, attached at the top and the bottom, and then you know, might be cheaper. I don't know, but as a general rule, I always put 1 basically at the top, 1 at the center, and 1 at the bottom, and it was a done deal. He's putting it here. I'm assuming that he's going to put 1 here, and that way he can possibly toenail into the plate here and toenail into the plate here to have that connected. Now, with advanced framing, we try to eliminate more wood. You know, when we've got all this wood in here, then more wood means less insulation. And so one of the ways to lessen this, or to increase our insulation, is to change this on center spacing. All right, so typically it's 16 inches on center, meaning that, you know, from center to center it's 16 inches. We increase that to 24 inches on center. And by doing so, we're going from about 17% framing down to about 12 or 13% framing. And that allows for more insulation to be placed in the wall. So,
and you're going to be using a 2x6 when you go to 24.
Yeah, you can't, that's load bearing, so you can't do that unless you up your stud size.
you can still actually do a 2x4, but you have to do you got to make sure that everything lines up. Let me explain that.
You mean you have to have your joist centered above your stud so that you don't have so much weight in between?
You got it.
Okay.
Okay. So let's say that we're gonna do our floor. All right, so these are floor joists. We're going to have our subfloor on there, and then we're going to have a sole plate on here. And then we're going to make sure that our studs are exactly the same spacing. In other words, they're right on top of each other.
Match the floor joist.
Exactly, match the floor joist. Then, by doing this, we can eliminate a double top plate as long as our trusses are directly lined up with this. Okay, so these would be our trusses, and everything is lined up, and all loads transfer completely down all the way through the entire building.
So that's code acceptable as long as alignment's in place?
Yes. Yep. Now, the reason that we put a double top plate is a couple of reasons. One, we tie the walls together, and two, you know, this might be, you know, it might be 16 inches on center studs, but then up here on the roof, we might have, I mean, it could be 19.2, it could be 24 inches. I have seen as much as 32 inches on here spacing. I mean, you know, so this transfers that load and allows that force to be placed and run down and to transfer that load. So that double top plate is extremely important when these do not match up. When these do not match, then this is a must. You have no other choice. You'll get called out in a heartbeat on that stuff. Now, let's think about that that intersecting wall, for instance. Okay, when we stud this up, we have that intersecting wall here, and we've got our studs in here, and we're going to do a top plate. We're going to do a double top plate. So the first plate is going to go all the way across. And so this one is going to be justified for the intersecting wall. And of course, this one is going to be justified for the through wall. Then we're going to go on top of that. And this one, this double stud or double top plate is going to go on top of the through wall. In other words, this is going to run across the through wall, and we're going to tie this in with a couple of nails here so that the top of this doesn't move. Then we're going to this other one that we're going to put up, it just takes up the space. We really, if we were lined up with our rafters on that, technically we wouldn't need that double top plate, only to tie in this wall here. So, this is really crucial. Now, if we get rid of the double top plate, how do we tie the intersecting wall into the through wall at the plate? And that is where we end up using what is known as a gang nail. All right, so a gang nail, and I'll show you a picture of it. A gang nail is a piece of metal that has a whole bunch of serrated edges on it, little points in here that have been bent over so that they can be nailed in place. And, you see this a lot of times in trusses. They use these to hold trusses together, but these also can be used on the top of the walls to attach those two so that we don't, so we have good rigidity up there and they don't come apart. Let me just do something. Gang nail on.
Before gang nails, did they just use to cut a stubby 2x4?
Not a stubby 2x4. Let me look up something right quick.
Why would you have to run one the whole length if all you're worried about is just attachment at the joint?
To get the same plane. In this picture here, they're doing a, this is, I don't know if this is an intersect, looks more like a corner. So this is the butt wall, and that means that stud stops right there. And I might be wrong on that. Let me look at it again. It's kind of hard to tell. Anyway, so let's say that this is the butt wall and this is the through wall. So this double plate here goes all the way to the outside of this wall here. Okay, it passes the intersecting wall. So when we go on this one goes all the way to the outside of this wall, and this one stops right there. Okay, so if we didn't put this one on, this would be at, we'll call this 1.5, we'll call this height 1.5 inch. And this one would still be at 0. All right, so when we're putting our joists on here, or our rafters on here, or our trusses, then if we had it, when we came to this wall, then if a truss fell on this intersecting wall, excuse me, then this would be 1.5 inches higher than this wall over here. So we just put this spacer in. And again, this spacer, if our rafters do not hit directly on here, we have to use a double to transfer that that load down on the stud. And that has to be there. But if we were to if we were to, line everything up perfectly on there, then the only reason that we put this on there is to keep this height the same all the way around the house.
Consistent.
Eric, I've been told that in situations where you're trying to use a single top plate, and especially if you're trying to do 24 on center with 2x4s, that you need to add more diagonal bracing.
I could see that.
I was just thinking that because it's weaker.
And not rely on just the plywood or the OSB, since that's kind of a long stretch.
If you happen to cross over that information, send that to me. I'd like to read up on that a little bit more too. Well, I'm not finding what I was trying to find, but again, talking about that diagonal bracing, in this particular picture, notice that he's got some diagonal bracing just sticking out in here. This is all temporary. This will be taken down, but he's got the OSB on here as well. So what Danny's talking about, and I don't want to be putting words in his mouth. I just want to make sure that I'm clear and you guys are clear. So when we're doing 24 inches on center, we're using less wood, meaning that we've got a longer space. Got a single top plate. Everything is lined up. And we need to put more bracing in here so that these do not collapse. Am I correct in assuming that's what you're talking about?
Absolutely. And, when we're relying on a 4x8 sheet of plywood, often if it's only going to catch the middle part of those two outside studs and you're relying kind of on a toenail of a sheathing nail, that you don't have as much structural capacity in each sheet as you would if it was crossing 4 studs.
Right. So when we're talking about doing the 2 foot on center, depending on most of the time, okay, so let me say this. Plywood was originally designed so that the grain of the plywood, of both sides of the plywood, run in the long direction. Okay, meaning that we end up with an odd number of plies on here so that we end up with both the grain of the inside and the outside running in the long distance of it. So with that being said, plywood actually is designed to be put on in this fashion. All right, but it's not. In a lot of cases, it's put on in this direction, meaning that it only covers a couple of studs. If it's 2 foot on center, it's only covering 2 studs. It's covering the center of this one. So you got half a stud there. It's covering all of this. And let me put it in a different color. So we've got a full here, we've got a half here, and we've got a half over here. So that's only 2 studs really. And especially when you're over here, you're talking about 3/4 of an inch that it's landing on this. Hopefully, pray to God that we've got all this lined up correctly. I've tried to hit a 1/4 inch space, meaning that this was off just a little bit, and I had a 1/4 inch space over here and 3/4 inches on this side, or not 3/4. I had an inch and a 1/4 on this side. So anyway, getting this dead on center in advanced framing is super critical. And by, going down through here and you're putting a nail at that 3/4 inch space right there, you don't have a whole lot holding on. So if you've got a lot of downward pressure on here, a force, let's say for instance, God forbid that it was a 2-story or 3-story house on this type of framing, then this is super critical here. And wherever these joints are, we would need to have some sort of diagonal in here to keep this from pulling out, because I'll tell you what, if if you've ever nailed plywood, you know, on the center of a stud like this, a lot of times when this goes on, you have to really kind of come back a little bit and toenail that nail into it in that fashion right there. If you go too close, then it's going to tear out. It's going to be worthless. And I've done this on floor joists where I just nailed it in straight, and then I stepped from here over to another one and shifted this, and it tore out. I've had that happen many a time.
Same thing with drywall.
What's that? Yeah,
Same
same
thing.
thing with drywall. Yeah, yeah,
Drywall's hard, you know, it's not as strong, so
yeah.
you don't have the strength there.
And you know, there are nailing patterns that are listed in the building code as to how many nails you need to put in a piece of plywood. And so when I'm teaching, I'm just, you know, I try to come up with ideas to keep it simple so that when you're on the job site, you're thinking about it. So when you're nailing along the edges, when you're nailing along the edges of this, you know, use the rule of thumb. That's how far they ought to be apart from your thumb to your hand there. But when you're putting the nails in the center here, use the pinky rule. So they should be about that far apart. So
Never heard that.
and
Unless you're building on the coast, and then put one everywhere there's a dot on the OSB.
yeah, yeah. There are certain, like California, for instance, they're so strenuous with the code. So you will see, you know, they, especially Advantex, let me get rid of this.
Do they make ribbed nails that would hold as well as a screw that you could use?
Yeah,
Yeah,
they make,
Most sheathing nails are ring shank.
They're what?
They're ring shanked, like you're saying. They have those.
Oh, yes, yes, yes. That makes sense, because then it just won't pull right out.
so at Advantex especially, they sell their plywood and they've got these little dots all over the place. And then you'll see the dots through the center. And then they'll have a diamond on it as well. And when the building inspector comes in play, he better see a nail in every one of those slots or he'll call you out on it. So, and there's, you know, they usually put these on at 16 inches on center, at 19.2 inches on center, and 24 inches on center.
A reference to earlier, do they now make plywood with the grain the other way where you can put it on horizontally?
Right now. I'm sorry, say again.
Do they make plywood with the grain the opposite direction so you can install it horizontally?
No.
Choose.
No, all plywood is got the grain going in that direction. So when you read, and I can't think of the organization that, you know, that the National Plywood Association, I can't think of what it's called right now.
Mhm.
So when they talk about plywood, they will specifically say that plywood should be hung with the grain running between the supports, meaning like this. Okay, so the grain is running between the supports. If we put it up this way, the grain is running with the supports, parallel to the supports. Maybe it says perpendicular. I think it does. Perpendicular to the supports, because there is an odd number of, I'm just going to draw 3 here, because there's an odd number of plies, then it's going to be stronger in this direction than it would be stronger in this direction than in this direction. Does that make sense? But because, you know, most of our walls are somewhere around 8 foot, this is the preferred method of putting the sheathing on, where, you know, in reality, this is what we should be putting it on, and it just don't happen. We do that on a floor. We do that on a roof. Why not do it on a wall? I don't know.
Yeah. Well, drywall's done that way.
Sometimes I've seen them put it the other way too.
Really? Wow.
Yeah. Oh yeah. Absolutely. Okay. So this is a really cool little site that I found. The do's and don'ts. David's do's and don'ts. Advanced framing. Let me get back to the beginning. Maybe that was the beginning. Okay. So don't bother. So he's saying don't bother about windows on layouts. Don't bother with using fewer cripples. Don't bother with using a single top plate. And don't bother with using header hangers. So let's go back to our little drawing here, and okay, so true advanced framing. So if we're doing advanced framing, then we're doing 24 inches on center. And if we're doing that, why not use 24-inch windows? So we can put a window right there and we haven't changed a single stud whatsoever. We can go down here to the next one and we can put another 2-foot window in here. Generally, these are like casement windows.
Well, it's actually 22 and a half.
Yeah. But they make windows that will go in between these, and you don't have to change a stud. Meaning that if we were using the regular type and we wanted to put a larger window in here, then we have to put cripples in. And if this is a bearing wall, then we'd have to put a header across the top of it, right? So we have to change this out just a little bit. So like I say, a true advanced framing, windows are crucial to making sure that they fit in between that. Now, what about a door? Well, a door is going to be obviously bigger, but what we want to do is we want to make sure that we have the placement of that door so at least one side fits in that 2x spacing where we only have to add a stud and eliminate, one of the studs that's in there. So, we have to pay real close attention to how we lay out our stud and how we lay out our windows. So if we're doing advanced framing, we just don't get on the job site and start slamming out studs like we normally would. This has to come from the design phase. So, when you're doing a true advanced framing, you might have a framing plan for that. And let me just give you an idea of this. So we do roof framing plans where we tell them, where this is going to be. And actually we do floor framing plans, second floor framing plans when we use large timbers. So these are 4x8. Actually, these are 6x8 timbers. So we have to plan ahead to find out where our baths are going to go, where our toilets are going to go, so that we don't want to cut one of these. So if we have to shift this one way or the other, we can do it in the plan on paper and then send it out, and they can follow this to lay it out. Obviously, you see that on one side we have 3 1.5 space over here, where over here we have 2 6, and then these are 32 inches on center. We go to the roof, the same deal. We do this so that they know where all of these things are going to run and hit and fall. Now, when you get into much more complex systems, such as this house here, this house is using a different type of method of framing. They're using steel trusses on posts. So in this particular house, we had to plan out where our posts were going to go. And, they have to follow this to the T when they lay out for their foundations, when they lay out for their wall framing, everything, so it will run out, because these there's going to be, typically there's no studs in between this because they're, I mean, we're going to put studs. That came out wrong. We don't have to have bearing studs. All of this inside is bearing free. So we don't have to have big headers in there. And we can slam insulation in here. This is, we're using 2 foot. Well, technically we could use 4 foot on center. I wouldn't advise it, but I'm just saying we could because all the bearing is on the posts. And so, if you get one of these posts wrong when you're trying to frame this, then when you get to this monstrosity, and I'm telling you, this has drove me nuts because I've only done this twice before, and it's a different thought completely because these actually run in a different direction. You're using the truss as the support, and you're putting purlins in at 16 inches on center or 2 foot on center to hold your plywood. And so to draw that is freaking crazy.
Too bad Revit will do all that automatically. It doesn't have a feature to do that, does it?
No, not this style. Now, a conventional roof, yes, but
Okay.
using metal joists, no.
Will it do wall framing? I hadn't found that option.
It does. It will.
Okay, cool.
It'll calculate and tell you how many you need. It'll do your estimating for you.
Oh, it won't draw it then.
I don't think so, but it'll tell you how many you need to order.
Okay.
Yep. So that gives you an idea about that. Now let's continue on. I'm running out of time. So David's list to do is 24 inches on center, 2 stud corners, the right sized header. All right. So the right sized header is, another thing that is super crucial, and you can go to your building code and figure out that very easily, or of course you can hire a engineer that's going to cost you out the yin yang, or you can go to if you're using an LVL, go to that LVL manufacturer that you're going to use, and they have tables in there, span tables that you can use in there. But in here in the code book, we can go in and we can figure out, how many, what can we do? And it's going to tell us that we can use a 2x4. The maximum spacing is going to be 24 inches on center. A habitable attic assembly supported by 2x4s limited to a roof span of 32 feet. So, there's going to be criteria in here that eliminates that. So if we go to 2 stories high, we can't use a 2x4 anymore, or we can't do it at 24 inches on center. We have to go to a 2x6 to do it 24 inches on center, or we can do it a 3x4 or a 2x5. Go find me a 3x4 or a 2x5, for the same amount of money that a 2x4 is. And you can call me Orville Redenbacher. So when you go to 3 stories, then that eliminates, even a 2x6 being used at 24 inches on center. So when you're using your headers, use the tables 602.71, and where we are in 602 point, yeah, so so here is our girder and header supports. We have to consider our snow load. All right, so if we're in Florida, we're using this. If we're in Montana, we're using this. So we could, easily use the 50 PSF snow load. When you're doing these, I always stress that you want to do these at, that 100-year snowstorm that you get, like we had back in 1993. So, it's, you don't want this thing to collapse because of one stinking snowstorm. But anyway, so it gives you, and I like using the 2012 model of the code because it gives me little pictures here. Nothing has changed in this chart from 2012 to 2018, except they took the pictures away. And I don't know why they took the pictures away, but so you can go in here and you can figure out what length that you need, what size you need. You know, do you need two 2x12s, you know, and a 28 foot wide house? Then, you know, we're going to have the maximum span is going to be 7'3". Different class for this, but I just want to kind of give you a sum of what is expected when you're trying to figure out these lengths. Now, once you do these and figure out what those are, you want to insulate the crap out of them. So basically what I'm saying is use the, you know, I try to go with the least that I can go with. So obviously down here, I've got 4 2x12s and I can go for a longer span. So if I'm using 4 2x12s and a 2x4 wall, then that's going to be wider than my wall. So there's nothing there to insulate. And I'm going to, you know, I'm going to have a cold spot there that's going to allow for heat transfer to cross through there. Whereas if, you know, if I'm doing smaller spans and I can get by with 2 2x12s, then I have a little bit of space that I can put some insulation in there to eliminate that movement of heat through there. One other thing to be said, and I think this was brought up in one of the PowerPoint presentations, is the use of seal. So, you know, going back to the double top plate method that we had here, this is a super big place for air, or excuse me, for heat transfer to go across. But if you take a strip of seal across through there, then you can eliminate some of that heat transfer by cutting off and making a thermal break there across through that. And the same goes that if you have a gang stud. So what are gang studs? So when we use gang studs, we might have a certain place, and I don't think I've got a gang stud on this at all.
They gang up on each other.
They do. So yes, I do have a gang stud. So let's say, for instance, right here, I've got to have a gang stud on, let me go back over to this there. So I've got a big old window here on the gable side of it. And because I'm using rafters instead of trusses, then all of this is considered a bearing wall as well. So I've got to have a gang stud going through here to support the ridge in here. So I put that gang stud in there, and you can see how, you know, we've got to have a header here to transfer all of that force down to either side, but we've got that gang stud in there, which is a solid piece of wood going from the outside to the inside of the stud wall. So by putting that piece of seal on there, then we can eliminate that transfer. And, you know, if we were really smart, we'd do the same thing here.
What's seal?
What's that?
What's seal? I don't think I've ever heard of that. Like a piece of wood or a bonding agent?
It's a piece of rubber.
Oh, okay.
Seal.
Now, is that the generic name, or is that a manufacturer or a brand?
Well, I mean, I've got two different companies here calling it the same thing. So let's go back just a second. Actually, wait a minute. Let me just stay right there where I'm at, and I might find a better pick there. So seal is made to go on the seal between the foundation and where you put, you know, where we've got wood going in. Okay, so we've got the foundation, and then we're going to put our stud wall on that. We put a piece of seal there to eliminate two things. One, any capillary action going up into the wood, and eliminate any heat transfer.
Is that, you said it's rubber?
No, it's foam.
Oh, it's a foam.
Yeah.
Well, it looks like it's backing on it, or
well, that was something different when you were looking at that picture.
okay.
I don't even know where that picture is now, but yeah. So that's something different. Don't look at this black stuff. Just look at that blue stuff right there.
Okay, the blue stuff is the seal.
That's correct.
Is it well, do you have to custom cut, or does it come in?
See how these lines are on there?
Yeah.
You can buy it 3.5 and 6 or 5, 3.5, 5.5, maybe 8. I don't know. And you can just take and rip down through these to get what you want,
Okay.
or you can just put it down there and forget about it. And some people go ahead and put it on the bottom. You know, they'll staple it onto the bottom of it before they set it up into place.
Well, that's a smart way. Yeah.
Okay, so we have talked about putting our framing at 24 inches on center. And we've talked about using 2 stud corners and ladder tees. And I found a nice picture here of the insulation. So, you know, when we're using corners like this, then it becomes, you know, problematic because we're trying to squeeze more insulation into it. And I just realized how come I couldn't hear nobody. I had my dadgum speaker turned off. Jesus. Yeah, I woke up about 4 o'clock this morning. My computer was dinging and carrying on. I just couldn't even turn it off. So I apologize. Geez, no wonder. I thought, man, ain't nobody awake this morning. So as you can see, you know, the insulation gets squeezed into places, you know, in the corner where we have a lot of studs. Now, one of the biggest problems that I see in insulation is they will take insulation that is, you know, made for, in this case, 5.5 inches. These are 2x6s, and they squeeze it. I mean, they just compact it down in here. So whenever you're taking, especially fiberglass insulation, and you're squeezing it into a smaller section, you're, in a sense, getting back to a solid piece of glass. So a solid piece of glass is a conductor of heat. And then, so, you know, glass itself is a conductor, but then, you know, when we're using it in a fluff like this, we're causing a lot of air pockets in here. And that is where we get the insulation, is all those air pockets. So when we're squeezing it together, we're making smaller air pockets. And like I say, in a sense, we're getting back to a solid piece of glass. So, you know, corners like this with the clips on there are better to use. Now, if you are doing a 2 stud corner like this, and we've kind of discussed this, then, you know, if we put the side, let me just open this up. So, you know, if we were doing a corner like so, then right here we have nothing to, you know, attach our siding to. So instead of doing the, you know, corners and then what we call them a butt corner, then turn my phone off.
So I don't use my glasses.
What's that?
You enlarge that since you're in paint, so I don't use my glasses.
I'm not in paint, but
Oh,
maybe. Yeah, there we go.
yeah, thank you.
Didn't know I could do that.
Yeah, so I don't have to squint.
Okay. So instead of using a butt corner, so what I mean by a butt corner is we put the siding trim on there, and then we butt the siding to it. We use the trim on top of our siding technique. Now, you know, if we were using lap siding, obviously this would be kind of problematic because, you know, we've got to put up with, I can't even draw today. I ain't had enough coffee. Then we have, you know, this is what we got to deal with. So, but if we're using like a board and batten vertical siding, or even a panel type siding, then this is very easily able to do. And we've got something to nail to on those. And the siding, of course, is nailed into those as well. So this is, you know, the best way because we're getting maximum insulation out of there. And that's the whole point of advanced framing, is to, you know, so that we can get rid of these and get more of this. So that's the whole point in advanced framing.
Are more and more contractors learning these techniques and
Uh, you'll find out that probably, I'm going to guess, say 80%, we'll say 80% of the contractors are kind of stuck in their way. They don't want to do, they don't want to do new techniques. They, especially like the guy that I do some drawings for, I asked him flat out, are you using any of these techniques? No. Well, why not? Because it costs me money. Inherently, what we're dealing with contractors. Excuse me. Brian at Red Tree Builders is one of the few builders that I know of that I have come in contact with who embrace the new building techniques. And he is getting, his houses are getting Energy Star LEED certification. That's the one that I was telling you about that tested a 0.17 blower door test. I mean, he's embracing these new techniques, and he's profited from it, because there are some people out there that look for contractors like this to save them money. Now, the people that seem to go to the contractor that I work for, they, here they are, they're retired from Florida and New York and Chicago, and there are two of them. They're already into their 70s, and they're building a 4,000 square foot house that costs, $2 million. They could care less whether it saved them a dime on an energy bill. All they want is a house, and that's what he's building. So.
And they probably drive SUVs also.
Oh yeah, absolutely. Yep.
What you just explained is exactly why I'm moving back home, because this 3D and Revit, I'll never be able to use it up here. These people stuck in the mud and in the, like you said, the 1960s. So, I mean, I can't even use my degree. Back in my town, I know modern.
Where is home?
Moore County, Pinehurst, Southern Pines, Aberdeen.
Okay, yeah.
Golf and horses.
Yeah, that's right. You told me that. Yeah, the bigger cities, the more progressive places, they're going to be more acceptive into stuff like this. And really, Buncombe County, if you look at a map, Buncombe County is blue surrounded by red. And so, I'm not kicking the conservatives, but they seem to be more, this is the way that I do it. This is the way that I make money, and I'm going to stick with it, and I'm not going to change type thing. So,
Eric,
yes.
Working in Atlanta, we estimated we had about 12 to 15% of all of the homes getting certified Energy Star and Earthcraft House. That's still a very small number, but it's a much bigger number when you figure 12% of the Atlanta housing market. But 12 to 15% is still a very small number of the builders using those techniques. And on your point of people just being used to their ways, I had one builder try to go to 2x6 framing. So he had 2x6s delivered on site, but he didn't communicate that to his framers so well. So they all put 2x6s on 16-inch centers and ran out of wood. That house cost him a little bit extra.
Yeah, communication is huge. Well, it goes right, but it's not only the contractors. We've got to get out there and educate the carpenters. And I guess the carpenters are probably worse than the contractors as far as, well, that's the way my grandpa did it, and that's the way I'm going to do it. So
change is hard for some people.
What is it?
Change is hard for people.
It is. Yeah, change is very hard. I'm one of them. I like what I do, but I have to, as an educator, I have to keep my eyes open to the new way, to the the way that it, what's up and coming. And when I teach, so here I am, I'm teaching, and you guys are going to be going through this, maybe finishing up in 2 years, if all goes to plan. What jobs, I've got to look ahead. What jobs are going to be out there in 2 years for you guys to take? So I got to teach you for jobs that may not exist. So, for me, it's really hard. But yeah, so, you said 10 to 15% in Atlanta, Danny?
think he said 12 to 15.
12 to 15? Okay. So I was,
Yeah, we estimated 12 to 15% of the houses being built.
okay, so
We're getting certified.
we're talking roughly 75% of the builders out there are still stuck in the old way of building, correct?
Even more
Yeah,
than that.
75 to 85% of the builders. And, you know, Atlanta's Home Building Association does a lot to try to encourage guys, and they offer all the classes for free and everything, but not a lot of people taking it up.
Yeah. Yeah, see, that's another thing. You know, I've seen a lot of the new green building stuff, and you know, they offer classes, but to offer them for free is really, you know, a community coming together to try to change for the better in the future. And there's a lot of these companies that are creating you know, these classes, and I'm obviously in the wrong, you know, I'm in the wrong business, because I need to be doing my own thing and charging you guys like what, $500 for a 3-day session. I mean, Jesus Pete. Some of these companies out there are, you know, raking it in. And the funny thing is, you know, contractors now have to have CEUs, architects have to have CEUs, engineers have to have CEUs, and that's a continuing education unit. So they are required to take classes, and you know, a lot of them don't have the time to set in, you know, a 16-week program like you guys are going through now. So they take this weekend deal and they pay out the yin yang for classes. So it's kind of sad. Okay, so here's that connector plate that I was talking about, you know, using in corners instead of a double top plate. Remember that you've got to stack all your lumber. So in here, let's see, let me go down here into page, and you guys can now download this as well.
Got it.
Okay.
Anything that's downloadable, I always go get it.
Yeah. Yeah. So, you know, they're talking about 24-inch grids and stacking it. So everything is, you know, stackable right on top of. So we've got, you know, floor joists, studs, trusses, everything is stacked in a perfect line. And it takes a lot of thinking to do this. You're talking about you know, buying the 2x6s and put them at 16 inches on center. I was working for a contractor one time, and so we were laying out a building. Let me get rid of this little screen right quick that you guys can't see. And it was, you know, it was kind of saddening. So I was the job super. So they laid off the floor joists from this side working in that direction, and they were 2 foot on center. And son of a gun, when they started laying off the joists, they laid off in that direction.
2x8s or 2x10s?
What's that?
Were they 2x8s or 10s, or what were they?
I don't remember. Just these were the floor joists, and they laid them off from left to right. But then when they went up to do the studs, they laid them off from right to left, which means the studs did not line up completely on top of the floor joists. And, you know, you've got to make some rules when you're doing these type of things to ensure that you're going to get these laid off in the right direction. So we could have went with a single top plate on here, but because they shifted these however far, I don't remember, they shifted these and they didn't fall in line, the studs didn't fall in line with the floor joists. Now we had to use a double top plate so that, you know, that everything worked out correctly. Even if this was, you know, down on the floor and we got the trusses perfect like this, because these were off, the building inspector would not accept a single top plate. He made us put up a double top plate, even though, I mean, we went back with the trusses perfect, but he wouldn't go with it because it missed that criteria at the floor joist. And I know that kind of sounds silly, but when I say, you know, ground rules, and so this was something that I always made sure that all my guys knew about. Everybody did the same thing. We always, if you're looking at the floor plan and this is the front and this is the back, everything went right to left, or excuse me, left to right as you were reading, and from front to back. So even interior walls, they always used the, you know, left to right, front to back, always. And that way, all of our studs, if you stood over here and you looked in there, then, you know, basically all of these walls, even in the centers here, should have lined up. You should see one stud down through there instead of a whole bunch of studs that's not laid up. And again, you know, it's, people get on the job site and they just go at it, and, you know, it's kind of like a bull in a china shop. They don't pay super attention. They're thinking one stud at a time. And that's, you know, I've always told people, when you're building a house, they think, oh, it's overwhelming. How in the world do you ever build a house? Well, it takes one board and one nail at a time to build it. And that's what you think about. But you've got to, you know, you've got to envision the entire scope of the finished product as you're building it. And a lot of, you know, you have to, it's just a lot of looking ahead. Alternating non-conductive framing, and it is a freaking nightmare. You think, you know, framing in, so these are actually put in at 24 inches, but they're offset. So you've got an inside and outside. These are 2x4s rather than 2x6s. So what this boils down to is there's no way for heat to, you know, to transfer through the wall. So when we have a change colors here, when we have a regular wall, you know, we have to think about heat conducting through here through the stud, right? So this is completely open so that we don't have any of the inside touching the outside except for the top and bottom plates. But look at this, top and bottom plates can be as big as a 2x12. I don't know about you, but have you priced a 2x12 lately? I mean, the damn 2x4s are 7 something. So, you know, this is rough. This is, you know, this is serious right here. So basically what that does is that puts insulation, you know, between the walls and the studs. So there's no transfer of heat through there at all. Did I talk about the rain screen here?
The what?
Rain screen?
No, no.
So the rain screen is another way to keep air flowing through here so that we keep moisture down. And so this is basically a stripping. Let me find a better picture. I know I've got one. Okay, so there's the picture that I was trying to reach. And so what's going on in here is we've put our house wrap on, and then we went back with furring strips across through here, about a, you know, a 1/2 by 1.5 furring strip. And then our siding goes on top of that. What happens is with this type of siding, water will sometimes get forced up in behind this, like on a foggy day or maybe some rain, wind-driven rain or something like that. Water gets up behind this. This is going to happen all the time, and that's why we put this house wrap on, is to prevent that bulk moisture from getting pushed into the building. However, this house wrap works kind of like Gore-Tex material, where it will allow for vapors. It'll stop the bulk moisture, but it allows for vapor air or vapor moisture to be sucked out of it like on a warm day. So by doing these strips, we're creating a rain screen, which means that if any bulk moisture gets up under the siding and against the house wrap, then it can run down and out across the bottom. Now, when we get down here on the bottom, basically what we do is we just, we can attach a piece of screen, and let me go back and show you this. Move.
Well, hopefully that siding is caulked, so it's air and moisture tight. If
Well,
it's done-
you'd think, yeah. Um, so here is the wall. Here is our furring strips. And then here is the siding that's on there. I'm going to do a crude drawing so that I can get through this. And down here at the bottom, basically what we're going to do is we're going to take some screen wire, we're going to loop it around, and we're going to staple it into the bottom of it. So this prevents any kind of vermin from getting up in here and building homes and so forth, but allows for any moisture that gets in here can drain down in this thing. And I have also seen these where they're vented across the top so that you actually get movement of air between these to absolutely just dry up any loose moisture that you have in there. So this is, you know, these are a good idea, but they're kind of a nightmare to build. You know, number one, if you're using extruded polystyrene behind this rather than plywood or OSB sheathing, then you've got to make sure that these are right on top of the stud that's in the wall. And then one thing that personally that I've had is I've had a problem with the damn things busted. So, okay, I'm looking down on this portion here. Here is my, we'll just draw the studs and everything. Here's my stud wall. Got my studs in there.
2x4.
Either. And then I'm going to use extruded polystyrene on here so that I get maximum insulation through here. Then I'm going to put these strips on there. So again, they're like a half an inch thick by 1.5 inch wide. And I'm going to nail these on here with my framing nailer. Because they're a 1/2 inch, I could stand a problem of them splitting. And that's what I've had a problem with. And then I'm going to put my siding on there, and I'm going to nail it on as well. So now I have 2 nails going through a very thin piece of wood, and it stands a better chance of busting. Now, if I can get it on and, you know, everything's okay, hopefully I can get away from the job site before it falls off, right? No, I want to make sure that I do a bang up job on this. And so, you know, care has to be really taken when putting these things up. And I have just, me personally, I have found that nailing them by hand is the best way rather than a nail gun, because a nail gun is going to shoot it in there and they don't give a flip about it. And so I've just had a lot of problems with them busting with a nail gun. So
That's a lot of pressure.
yeah.
What about staples, like the thin, what they
Crown
call?
staples, yeah, you could do crown staples. Yep. That would probably work better. I didn't think about it, but only because the only reason I didn't think about it is because I don't have one. I don't have a crown stapler. So
Oh, that's a good investment.
yeah, it is. It is. Okay, so now let's make sure that all right. So advanced framing a little further. So this is, kind of where we're talking about where the architect comes into play. Actually, it is where the architect comes into play, or draftsman. Don't want to leave myself out of it. So let's build a house. All right. So, well, for one, this is a house that typically, that most, I don't know about most, but I would say, some people want this. An architect, this is the floor plan of a house that an architect's going to design, So, they're not thinking about material. So we have been talking about 20, let's call it 24 inches on center spacing. So why not design the house around 24 inches? So instead of having, crazy shit like 67 feet, no, not even that. We'll make it 67 feet, 5 inches, where you're going to lose a whole bunch of material. Let's make it 40 feet, period. All right. By 20 feet, period. All right. So that's kind of small, but anyway, so when we go to put our plywood in here, then, we're using whole sheets, and we've designed it to where when we use half sheets, so we basically offset these. We'll start off with a full sheet, and then we have a half sheet, and then we're going to have another full sheet. And then we're going to go back to a half sheet. Make sure that this house is designed to where we don't have a quarter of a piece, or we have we have to a little bit hanging off here. We got to get rid of 6 inches. And, it's just a pain in the butt to have to cut plywood more than than we have to in a full sheet and a half sheet. So, here we've got 4 sheets. Well, guess what? Right here, we've got 4 sheets. We've took half of it over here and half of it over here. Back to four full sheets. And then we're going to use the half and the half here. All right. So when we're designing that house, really, we need to be looking at a half sheet of plywood. So we're talking about 48 inches by 48 inches. And if we have to cut our plywood any more than that, then, we're kind of spinning our wheels when we're talking about this. Well, the same is to be said about our roof as well. If we can design the house plan to be utilized to where we have a perfect usage of the plywood here, then when we get to the roof and we design it so that it uses, perfect sheets of plywood as well, then we don't have any waste. All right, less waste. One of the things that always came to my mind when I'm talking about waste is, you guys know who Norm Abram is?
I know that name. I know I've heard it, but I forget who he is.
This old house?
Well, he started out this old house, and then he went to the New Yankee Workshop, right? He started.
Oh, yeah.
So why was he hired? Well, one of the reasons was the producer was going around, and he was trying to find, contractors that would be willing to do a show. All right. So this old house. So Norm Abram, along with that other guy, and I can't think of his name right offhand, who sold Sears tools for a long time. They were the runners of this old house.
Bob Vila.
Bob Vila. There you go. So why was Norm Abram picked? Because his job site had little to no waste whatsoever. From what I read, there was less than 3 inches of plywood thrown away, and less than 6 inches of any stud or dimensional lumber that was thrown away on his job sites. So he got the job because he had less waste on his job site. So he was, obviously he was pretty conscious as to, the material cost, the material usage. because for years, this material has cost us absolutely nothing, really. When I first went into business in 1984, a stud cost me 81 cents, if I remember correctly. And today there's at Lowe's yesterday, they were 742, I think they were. A stud, not even a 2x4x8, a stud. So, using this and trying to, utilize the most material with less waste is another key. Now, keep in mind, all of this stuff that I'm talking about here is, that gives you brownie points, I guess you could say, with the LEED technology or the LEED certification stuff. So all of this that we've talked about is leading up to the LEED stuff. So keep that in mind as well.
Leading up to the lead.
Up to the LEED.
Oh, I was, yeah, if you went as small as a 2-foot base increment, you would pretty much, and I never thought about it. So now the slope is usually determined by, if you want to live in it or not, but hell, you should use this method to determine the slope, not the other way around.
What do you mean the slope? The slope of the roof?
Yeah.
Oh, okay. Yeah.
Because it's a direct component that.
Well, that's exactly what I'm trying to teach you guys. Yes, you're absolutely right. So if we went, if we just decided we were going to do a 6 and 12 pitch, okay, we're going to do a 6 and 12 pitch, and it's going to take 3.5, or we'll say it's going to take 30.5 sheets. But if we moved it to 7 and 12, it's going to take 32 sheets. So do we want to buy a whole extra sheet, or do we want to throw away half a sheet? So, that kind of thing is some of the things that you have to look at when you're designing that, for sure. And,
I'm gonna start doing that.
Also, let's think about our,
The walls.
let's think about our overhang. Okay. How big is this overhang?
It'd be 24, because that's,
in the northern states, we want this as small as possible. All right, because we don't want to have any ice dams and stuff on here. But maybe we want, we want to be able to cover in the south here. We can have big overhangs so that if we have windows down here, then we can use that overhang to cover this window in the summertime so that we don't have heat gain in there. However, to determine this, why not go back to this piece of plywood here? We can get two pieces out of it at 24 inches on center. We can get 3 pieces at 16 inches on center.
mm-hmm.
All right. I think my computer just froze. This is the overhangs that I'm required to do on this house. Can that be, can you get that out of a piece of plywood?
18, well, not without waste.
Exactly. Why not make that 1'4"? I don't know. I don't argue with him. He pays what I do, and I just do the drafting and keep my mouth shut. And especially stuff like this, what the hell is that? Well, it's stuff that looks pretty. It's stuff that sells, so it's just an overhang, an extra overhang to give it some more oomph.
Pizzazz.
What?
Pizzazz.
Yeah,
In jewelry, they call it bling.
Yeah, well, that's bling, that's for sure. So, that's what you're dealing with, so anyway, that's what you should be trying to do, is get your maximum usage out of a piece of plywood. And the plywood is a lot of times what should be used to design by.
You just made me realize something too, that
4x8.
You've got to consider your overhang and your roof slope at the same time. Otherwise, one or the other is going to throw you off and you still have waste. So
Yeah, well, it's not always a question of using 100% of the piece of plywood, but if we can use 95%, it's a hell of a sight better than using 40%. Okay, so we're shooting for this, but we're okay with that.
Oh, yeah.
So we're not trying to get 100% absolute total out of that.
Well, my OCD perfectionism will.
Yeah.
Well, on the computer, it's easy to figure
Oh yeah,
out.
it's easy to do. Well, I mean, CAD in my earlier days when we actually had to have a calculator. Can you believe that? We had to have a calculator to determine all of these numbers. We had to sit here and count all of these up to see if they came up to 36 feet. So,
Yeah.
hell, nowadays we just slap it on there and don't even think nothing about it. What we're worried about is actually getting it. For instance, if I'm doing a measurement now, if I'm trying to get to this wall here, just make sure that I don't miss it like that, and I come up with some crazy dimension on there. So, and another, I don't know. So, are you in the architectural degree or architectural certificate program?
Me? No,
Yeah.
I'm in the 3D CAD technology 2-year degree.
Well, did you take any architectural drawing stuff?
Oh, hell yeah. I took it under John.
Okay. So what is the smallest increment that you design to in a house?
Well, which aspect? What are you referring to?
Okay. So when I'm going to lay out this house here,
You mean the room size?
I mean, room size, placement of walls, do you, so for
I
instance,
try to stay within 6 inches myself personally, but I learned all this before I took his class. I mean,
right.
nothing less than 6 inches. But I try to stay on a 1 foot or even a 2 foot grid because of drywall.
Okay. Well, maybe I'm missing what I'm trying to ask. Okay,
I put all the odd dimensions in the closets and halls.
So, when we're dealing with, when we're building, we're working to 3.5 inch and 5.5 inch. A 2x4 and a 2x6 have that 1/2 inch on there. So when we're placing walls, if I come up with a dimension of 4'3" 3/8 or 4'3" 1/16, I'm going to move that wall so that a 1/2 inch is the smallest increment that I have. And if you look at anything on this, you're not going to see any dimension, even on the first floor plan, you're not going to see any dimension less than a 1/2 inch.
I agree with you, but I try to factor in the finished product with drywall or whatever. So I'm figuring either a 5 inch or a 6 inch wall. I actually did a drawing with a 6 inch wall in his class and realized, well, that's not reality. I had to go back and redo the whole damn thing over with a 5 inch wall so I could get my inside dimensions the way I wanted them.
Okay, how are you getting a 5 inch wall?
3.5 and then 2 5/8 drywall. I think well, can you still get 3/4 inch drywall or not? I know that
You can, but you don't need it. Why would you put 5/8 inch in on a house?
Well, I mean, that was common a long time ago. I guess they've gone back down to a 1/2 inch now, but it was pretty common a couple decades ago.
Well, if I have a 3.5 inch stud and I add a 1/2 inch of plywood, or excuse me, drywall on either side, then I end up with 4.5 inches. So it's almost impossible to get rid of that 1/2 inch because we're working with 3.5 and 5.5. So if I had 3.5 inches and I had 5/8 inch drywall,
That leaves you.
on either side, then I end up with 3 3/4. So all I'm saying is, try to, whenever you're doing anything, when you're laying out for the centers of your windows, for the centers of your doors, for in between, in the old days, we used to dimension to the center of the inside wall, which always ended up with 1/4 inch or 3/4 inch. But With CAD, you can't just come over here and grab the center of that wall because it's not going to give it to you. So we have changed over to doing side to or face of wall to face of wall. And these are, you know, this is not including any kind of finish on it whatsoever, because when the framer gets in there, he's going to, you know, he's got a 2x4 in his hand. And so that's the dimensions that are going to be for him. And I just realized that.
Well, you almost have to dimension the center for a frame or it won't come out right.
What you mean? Center of what?
The center of the stud.
How's it not going to come out right?
Well, like we're calculating the finish, which is the 2 1/2-inch pieces of drywall, which makes it 4 1/2. Well, if you dimensioned it on a 4 1/2 wall, if the framer went by the face to face, it'd be wrong. You got to dimension to the center to place the stud where it actually needs to go, because then you got the 1/2 inch on either side.
Well, that's what I'm saying. I mean, if this is the stud,
Now, is that a 4 1/2 inch or is 3 1/2?
that's 3 1/2. We don't put any. I'm not going to put any.
So you put a finish wall in. You always do a stud wall.
Well, that's because that's what the you know, that's what the contract. That's what the carpenter is going to be framing. He's going to be. He's not. He's got to put the studs in before he puts any finishing on. So if I were to dimension with, let's say, for instance, I put a 1/2 inch sheetrock on this side and I put a 1/4 inch piece of paneling on this side, and then the homeowner comes in and changes that. Well, I would never I would never dimension this to the finish, because this way I can put any finish I want to on there. It don't matter if it's 6 inches of finish. I have my stud in place, and that's what the carpenter is going to start with. He's going to start with the stud. And, you know, the same carpenter may not even, he may not even be putting in the finish. He may not, and maybe he's just a good old boy framer. He goes in there and does the frame, and he don't come back and put drywall and
drywall is usually done by a different discipline.
Yeah, so we want to make sure that we dimension to our framing and not to any finish whatsoever. But my point is, you know, try to reduce that down to a 1/2 inch. Don't get any 8ths, don't get any 16ths, nothing.
Oh yeah.
Halves or holes, that's it. Halves or holes.
So all your floor plans are designed from a framing perspective, because when you look at a plan, well, architecture teaches you to draw with a finished wall. So that's why you either have 5 inch or 6 inch, you know. I mean, that's typically what we've always used. So I've seen anybody do it this way, because you're coming at it from a more practical aspect.
Okay. Well, like I say, this is the first thing that's going to be put in place. You know, when we go and build, we're going to be putting these studs up before we put any finish inside or out. So the stud is it's the centerpiece. It's the backbone. Let's just say it that way. It's the backbone of everything, because without it, the finish is not going to stand up.
That's what's nice about Revit. It does it automatically. I mean,
Yeah.
It's AutoCAD, you got to think about it.
You gotta
I might
think.
start doing it that way and just add the finish later, but I still want to have nice whole numbers between wall faces, like for drywall. you know?
Yeah. Okay, so insulated headers. If any of you follow the Journal of Light Construction, they have a great site and a great magazine, and I use a lot of their articles and stuff in what I teach. And I like it because they have debatable points on here, such as, you know, insulating that header. Well, which is better to insulate? Put the foam on the outside or put the foam on the inside? So to kind of back up and explain this. So in the old days, if we had a wall that was using a header, we would use the building code to size this. All right, so let's say that we're using a 2x4 stud wall, and it calls for, the span calls for two 2x10s to be used. So if, and this was what I was taught when I was first in school. And this was, this had, absolutely no pre-thought design in this at all. So my instructor said to build a proper header, because these are 1.5 inches, then if I were to put 2 of these together, that would be 3. Well, this is 3.5 inches. So what do you do with that other 1/2 inch? Well, you take a piece of plywood and you stick in there. That's what I was taught. Not going to lie you, to take up that space. All right. So you nail or screw all of this together and it becomes one great big heavy duty unit. And it used to be in the code book, and it's not, I don't think it is any longer. They would actually count this 1/2 inch piece of plywood. So if you used just just two 2x10s, then it would do, it would span an X feet and inches. But if you added a 1/2 inch piece of plywood, then, you could do the X plus 4 inches, because they would actually add that in to the span carried.
Only 4 inches? You think it'd go further than that?
I'm pulling this out of my ass. I don't know. It's been a long time since I've looked that up. So it could have been a whole 1.5 feet more. I don't know. I'm just using this as an example. They don't do that anymore. So, when we talk about, lengthening these, this is now steel. All right. So you can use a flitch beam, which is just a 1/2 inch piece of steel and it adds, many feet to this. However, we stand the problem of heat transfer through conduction massively. Okay. Because everything's touching out through here. So it became kind of a secondary practice for us to do, if the code called for 2x10s, we'd put the 2 2x10s together, and then we would put blue board between it. And I keep calling it blue board because it's green and pink and all kinds of colors. Now, it's extruded polystyrene, and when it was all blue. It was Dow extruded polystyrene, and it was blue board, about the color of this pen actually here. And so we would put that in there, and then of course we would sandwich that together, and we thought, oh man, we're good to go. I mean, yeah, it put in a thermal break here, so that when we had heat transfer, it hit this point here and it's pretty much stopped. So we've got to put in even further thinking. And that's where this site here decided that, or the Journal of Light Construction, they do these debates. And so, okay, so better building performance, insulation to the exterior, the rigid foam keeps the outside, keeps heater, what am I trying to say? 2 inches of foam on the outside keeps header warm. Okay, we keep this header warm. We have a 1/2 inch airspace in there. I don't know why we have the 1/2 inch airspace, but what benefits does it have? Well, let's go over here and look at this. So if we put the insulation on the inside, then maybe we catch some water in here, because this is this has a very, very low perm rating on it. And anytime you have a surface touching a surface and water condenses in there, it stays. Remember that, we talked about the ink quill pen, I think it was maybe in here. I can't remember if
Yes.
My classes are starting to get kind of blurry now. So, it's going to stay there, and to get rid of it, then how do we do so? So it has always been, I have always been taught that no matter what you're insulating, you always keep the insulation to the inside. All right. So, you know, if you're going to have an airspace somewhere, that airspace needs to be on the outside, because you need to always keep your insulation touching on the inside. So that is like the number one rule. And by doing this, then we're allowing moisture to come in here, condensate in there, and then we can possibly get some rot in this header. Why not split it apart? Same reason. If we were to put this over here, then condensation is going to get through this wood, because wood is porous, and it's going to settle in between the headers and could possibly actually rot both of them rather than just one. So the preferred method is having the foam to the outside and keeping the header warm, as well as the rest of the room and everything.
Question, would you ever put the 1/2 inch gap between the foam and the 2x4?
Well,
Goodbye.
again, you know, it is inherent that we try to keep the, you know, put this up for you, Blondie. So it's, you know, we want to keep all of our insulation to the inside as much as possible. So by moving this air gap over here, then you're pushing the insulation to the outside. Even if we're, you know, doing we had our insulation out here and having our gap here, then we're allowing for, you know, condensation to get stuck in there, and we don't want that to happen.
So you want your vapor barrier on the outside.
No,
I mean, not vapor, your air pocket or whatever
you want to keep as much of the wall warm. Let's say it that way.
Well, the space is on the outside the way they're showing it.
What's that?
The airspace is on the outside. That's where you want it.
Yeah,
Okay.
that's why they're saying it. Yeah.
Yeah.
Yeah. Let's see if it says anything about the airspace. I don't know. Let's see. Most builders use 2.5. Okay, so yeah, so if we're using if this is 2x6 wall, they're going to use a 2-inch rigid foam in here. Now we could go back and put a 1/2 inch in there, but if, you know, they're not doing that, they're not going to put that extra 1/2 inch in there. I don't know why. If I was really being super energy conscious, I'd probably put that extra 1/2 inch in there. I don't know that the airspace in this particular instance would benefit us whatsoever. It'd probably benefit us to put more insulation in there, because we're going to try to stop that, you know, that bulk moisture from coming in at this point during our house wrap. Make sense?
Yep. There's mud.
Clear as mud. I don't know about y'all, but the pollen is starting to build up. I've been.
Oh, it's already hit you?
Yeah. Yeah, the maple blooms. You got to remember, we're probably a week earlier than you guys.
Oh. It's not bad here yet.
Make sure that I'm not missing anything. Did I talk about raised heel trusses or knee walls?
Yeah, we've touched on it a couple times.
Okay. All right. Well, I don't want to sound like a broken record. All right. That is, and that's all I'm gonna say about that.
Okay, Forrest.
All right, so that is, we're good. I think, let me check, again, oh, make sure that you look through this down here at the bottom. I want to show you this checklist. Very, very good checklist. It's actually a rubric. It's a building rubric, and this is something that LEED uses as well. And a lot of these probably cross over. Well, let's do it this way. There. So a rubric. If you're not familiar with rubric, then a rubric sets up different standards so that you can end up getting a better score and stuff. So let me go down here to, okay. So we've talked about the footprint size. So in this first column, you get no points, 1 point, 2 point, 3 points. So in the rubric, when we're looking at this odd dimensions, okay. So, odd dimensions, that means, we've got some weird stuff going on there, 3 inches, 7 inches. And so that's not going to get us any points at all. And that is, look at that, standard construction. Okay. And that's what we've been kind of talking about in here. Standard construction is a tunnel vision type construction. You just get it done, get it on, move on with it. Light green construction, you have smart sizing, even dimensions in 2-foot increments. Then you go to medium green construction, smart sizing with footprint divisible by 32. And then you have dark green construction, which means smart sizing with footprint divisible by 32, long axis of building running east and west. And that's something I didn't talk about, running east and west, 2-story construction.
That floor plan, we're referencing floor plan when it has footprint size, is that what it's for?
Yeah. Footprint size. So, if we're talking, how big is this footprint?
Like you just described.
Yeah. I'm kind of confused. And I got to read on this. Why would they want to be divisible by 32 rather than
Plywood.
So
332s is a piece of plywood, long ways that is.
Okay, yeah. True. So that's even, yeah, you're absolutely right. But at this point, you got to think about the plywood. Will the plywood span that? And you're going to have to check your span, your plywood. Let me pull that up real quick.
Oh, you mean 32 inches on center? Well, can you do that?
Plywood.
Well, you probably got to have a 2x10 or 2x12 to do it with, don't you?
Plywood. I don't know why I always want to say plywood instead of plywood. Plywood span rating. So when you're looking at your plywood, you've got to look at this, you got to look at this span right here. And so, when this plywood is rated, it is rated to be run with the grain. And I think I've talked about that as well. When you're talking about plywood, you have an odd number of plies and the grain on the inside and outside run in this direction. Okay. So when you're looking at this rating here, 24 inches on center, that means that it will only span 24 inches there. We can't get a max. That's our maximum span is 24 inches, and that's a sturdy floor. So we're talking about, all right, notice that the thickness, this always gets me. The thickness, is it 3/4 of an inch? It's 0.703. So I'm just gonna check something right quick.
A little more than 5/8.
703 inches.
Actually, it's 9/16.
It is
That's close to
it's closer to 18 millimeters.
Well, we don't
All
think
right. And so when you're looking for plywood, remember that the United States is the oddball,
That ain't right.
and most of the machines that we use are built outside of the United States, where everything is millimeter. And so these are just as close as we can get to the millimeter and show it in inches. So, you know, right there it is, 18 millimeter exterior. And that's what is actually, that's the actual, this is the imperial standard equivalent. All right. So sheathing is a different story. Sheathing goes up and down vertically, so you don't have any weight being pressed down on it. The only thing you have to deal with there is wind loads and so forth. So you couldn't use, you know, we still can't do 32 inches on center. And like I say, that's, you know, you'd have to have pretty good, you might have to have an inch piece of plywood before you get to 32 inches on center on that. But anyway, so look through this checklist, and it is a very, very thorough, comprehensive type little rubric that you can use to build a house. And so you could get, different ratings on here, and you know, the higher the rating, the better. And then so you can, this is kind of like the way that LEED works. They use rubrics on that as well. It's a little bit more convoluted, but it works generally in the same principle. All right. What's that?
You give us that one? What's it called? Green Building Guide?
Yep, that's the one I just put on there.
Okay, yeah, I've had it.
I thought you said you already opened it.
Yeah, there it is.
All right, any questions about advanced framing? Anybody think of anything that I have forgotten? I think I've covered it all.
We didn't mention much on the materials like truss, like engineered joists or finger joints. You know, a lot of people trying to reduce their lumber usage are going to go to a web truss or an eye truss or even finger joint studs now.
Yep. Okay. Very good. All right. So eye joist. So what is an eye joist? An eye joist is just that. It is a flooring member that we can, you know, we can make as long as we want, and it's an engineered floor joist that really is the way to go nowadays. But there's certain things that have to be taken into place when building this. Now, when these originally come out, when these originally come out, you can see from this picture here, it had an OSB, and even before the OSB, it used plywood. When they very first came out, they used plywood, and then they used dimensional lumber across the top and the bottom. And so it's, you know, these were good, you know. And here's that finger joint that Danny's talking about there on this one. So we can make these as long as we need to. However, because of these finger joints here, these can actually add a weak point in it. So we switched over to, not that one, we switched over to LVLs. So, and this is, let me see about this. Yeah, I guess it is. We switched over to an LVL, and even though this is laying down, it really doesn't add a whole lot of structure to it because it's laying down, but we don't have a particular weak point in it. These can be, you know, we can stop this layer here, 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 and we can end up with a continuous strong flange on this thing that has no particular one weak point on it. So these are designed to carry load in in a bending fashion. So when we're thinking about that, so we have, there's different loads that's going on. So we have compression, we have tension, we have bending, we have twisting, shear, and a whole bunch of others. But the one main thing that we deal with is this bending. So like I say, these are designed for the bending motion. So what happens if we have, that's not even the right one, doggone it. Well, I'm gonna go ahead and use this as an
How
example.
about the one in the middle? Is that it? The one over in the middle?
This?
Down, 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 right there.
Well, that's what I had a minute ago, but it doesn't show exactly what I'm wanting to, the point that I'm trying to get to here. That one does. Let me open up this. Okay, so these are designed for the bending. So, we can hold it over here on the end, we can hold it over here on the end, and we can put stuff in the middle of it. And these are designed for the bending motion. However, we stick a wall underneath it like this, then we prevent this from doing its flexing, moving thing. And what can happen, especially if there's another wall on top of this that might be bearing, then these are not designed for the compression, and they can crack right down the middle of it. So what happens is we have to go in here and we will put in what is known as a squash block. Let me move over to here where I can explain that a little better. So we have our eye joist, and let's say that we have a wall that's going to run underneath it, and then maybe we have a wall that's running perpendicular on top of it. So the weight from this wall pushing down can buckle this piece of OSB in here. So what we have to do is we have to take 2x4 pieces in here and just place them right up beside of it. And what happens is we're transferring that weight. That weight is coming down. Instead of going across here, it's going to transfer over and then on down and so forth, so that we don't, and this is called a squash block. Squash block. How you spell squash, Jimmy?
SQUASH.
Okay, squash block. All right, so that's just to transfer that space. Now, how long can these be? They can be forever long. Now, they not necessarily are going to span that long, but they can be put down as a single unit so that we don't have any lap joints. When I say a lap joint, say we've got a girder here and we've got a joist coming in, and then we're going to lap it and continue it on the other side. This, those eliminate that. With an eye joist, then we can just go all the way as long as we want to. All right, so how long can we buy them?
40?
An infinite. Now the question is, how long can you haul them down an interstate highway?
60?
53 feet.
53 feet is the maximum without a special permit. So, if we had a house that was 53 feet long, we can order these. Now, I'm not saying it's going to free span all this way, because if it did, it's probably going to be about 60 inches tall. So if we go over to a span chart, let me go pull it in the span chart. So if we're looking at a span chart, you can see that those come in different sizes. So when they're designing these, it could be any number of things. So in this particular design, we're, 14, 16, 16, 16, 16. So we're trying to keep it within a unit that is workable. I mean, if we had this thing 3.5 inches wide and it's 4 foot tall, at some point, all we're doing is adding more dead weight to it, and it's going to lose its deflection in there. And we'd have to move on to something like a floor truss. And that seems to be, that's another thing that is becoming very popular nowadays, is floor trusses, because we have all this beautiful space that we can run electrical and plumbing and HVAC through. Whereas if we had these joists, there are very certain rules as to where you can cut and where you can't cut.
Are they cost effective? That's a lot of-
Absolutely. Absolutely.
And they're obviously prefab, so they're going to be stronger.
Yeah.
I mean, that's not the word I'm looking for.
So you can only cut them so much, and you can't cut the flanges, the top flanges, or the lower flanges at all. So there's, this whole table here is designed to help you understand where you can cut and where you can't cut. So, by using a floor truss, it's just like a roof member. You can, and these are, these can be put 2 foot on center, and as well, and they work great. Matter of fact, the company that I draw for, if you'll notice, going back over here to there they are. First floor is done all in pre-engineered floor trusses. So that
What's the height on that?
1 foot 8 inches on those. But those, again, depending on your span, those could be different heights as well.
What's the boards running through them for?
What you mean?
The boards that are running perpendicular going through them.
You talking about here?
No, further over.
Here?
Yeah, what's that for?
Stability. That could be an LVL. So let's go back over here just a minute. So we actually use LVLs, and that's the way we keep it to 1 foot 8. If I were to do this whole span, 28 feet, without this LVL in the center of it, then this might be twice as big, twice as tall. So when I'm designing it, I'm going to go ahead and put some gang studs in there, and this doesn't show it, but there is an LVL. Why do I not show that LVL in there? Anyway, there is an LVL that runs down through here. Let me go. It runs down through there, and then when we do our calculations for our floor trusses, then we only have to basically do a dead load at 13.1 rather than doing a dead load at 26.10. So that way we get a smaller thing out of there. Now, if we didn't use a floor truss, we're probably going to have a whole, or an LVL, okay? And I'm going to talk about an LVL here in just a second. If we didn't have that, then we're probably got a whole bunch of posts down here, or we're going to have to redesign this with a wall in the middle of it with a haunch slab. So that could be, this is also used to keep the trusses together, upright. So it's a, what am I trying to think of? It's a purlin, it's not a purlin. Anyway, it ties them all together. Strong back, thank you. It's a strong back, a strong back.
Strong back, okay.
Yep. Yeah, right there's the word right there, strong back. Let me just go pull that one up. So a strong back is a method of putting a piece of wood in there to tie everything together. In a ceiling, when you're doing trusses, I really need to close some of these. when I'm doing a roof truss, you will see generally, and you'll see these in rafters as well. They'll take a 2x6 and put it onto a 2x4 a lot of cases, and they nail these together, and you'll see them on both sides.
Oh, yeah, I've seen that before.
Okay, that's a strong back. Basically, when you have a whole bunch of stuff in here, this comes in through the center of it and helps tie this all together so that they don't move back and forth. And like, for instance, if somebody come up here and was walking through here, then it ties all of these together so that we have the weight being transferred across a greater spread of members rather than a single member.
I think they use that in mobile home construction because I used to stand on them when I was running wire up there.
It's possible, very well, could be. Okay, so LVLs are like a piece of plywood. So let me back up here just a second. So when we're talking about plywood, we are taking, a piece of veneer. Let me go a little bit further. We take a tree and it's turning like a lathe, and we have this big long blade that is peeling off a thin sheet. Okay. And it's, we take it down, and this thing, what's left is about 6 inches, I think it is. And then we take these and we orient the grain. So in this first one, the grain's going to be running this way. And then we're going to put a second one on top of that, and the grain is going to be running this way. And then the third one is going to be running this way, and so forth, and so forth, and so forth, until we build up to the thickness that we need. And then we cap it back off with one going back in the same direction as our first one. Okay, remember I told you we have odd number of layers on there. So this is the way that plywood is built. So that way we have strength both in this direction and that direction. So that is plywood. So let's talk about an LVL. LXL, let's try LVL. So the same method is being used here. We're taking this tree and we're rotating it, and we're pulling off a big old piece of very thin wood, and we're going to put the first ply down in this direction, and we're going to put the second ply down in this direction, and we're going to put the third ply down in this direction, and so forth, and so forth. And it doesn't really matter how many plies we have because they're all going in the same direction. So what does this give us? This gives us a huge, strong, bending motion beam. Okay, so you guys remember the difference between a beam and a post? A beam.
Horizontal?
Nope.
No.
Is under bending stress.
Oh, that's right.
A beam is under bending stress, and a post is under compression.
Compression, that's right.
Remember that. All right, so this is a beam. It is under bending motion, and we can make this as thick as we want, and we can make it as tall as we want, and we can make it as long as we want, up to 53 feet without it being permitted on DMV roads. Okay. So with that, we have discerned that we can do long tables on this. We can, we've tested this. We know what kind of glue is best. We know what kind of thicknesses is best versus what kind of heights is best. And we have, we can do LVL spans. I would not suggest using a generic span table at all, ever, such as this here. Never, never, never. Go to the site of whoever you buy it from. If you're going to buy them from LP, go by their technical guides, because they use different glues, they use different engineers, and they've had different testing methods on it. So, you know, here is that LVL with an eye joist. So we're using the LVLs down here to help support these eye joists, or we can hang them on there. That, you know, with that, then if we have,
Are there code minimums for a lot of that?
not for LVLs, the code actually goes in there and says, you're going to go by what the manufacturer says. So going back to this, the raw drawing here for just a minute, let's let it go through its thing. I'm sorry, guys, it's going to take a minute. This is a huge house, but I wanted to show you where LVLs have to be used. I mean, there's just nothing else that can be used other than steel. And it's going to take a minute. And I wish I could stop it in the middle of it. I just forget about it. And well, it's not going to open up. And it's froze. Okay, good. All right. Let's look at this here. I have an 18-foot wide garage door right here. So in this case, we're using a pre-engineered steel truss. The house that I'm doing this one for is actually a company. It's the owner of a company that they build these trusses here in Morganton. So obviously he's going to use his product. So, but you know, if we were doing a wood house, how in the hell would we span 18 feet? We could use a steel truss. We could use a wooden truss, or we could, you know, 18 feet, we could go in here and we could look down here, 18 feet span. So we're going to use a 3.5 inch wide beam or a 5.25 inch wide beam, depending on if we're using a 2x4 or 2x6 wall. And depending on the size of the house this way, and going back to that, I'm going to be using 24 feet. So under 24 feet, this is either going to be 18 inches high if using a 3.5 inch beam, or it's going to be 16 inch high if I'm using a 5.25 inch beam. So that gives you an idea of how those can be sized. But again, use the manufacturer that you are purchasing the LVL from. Do not use a generic table because you'll get bit in the butt if it fails. So, well, anyway, basically, let me just go back. Here's the best way to do it. Notice the note. Nope, not that one. Pre-engineered steel truss header with all specs by manufacturer, period. That means that whoever you buy the LVL, the steel truss, the wooden truss, whoever you buy that from, the manufacturer is going to be responsible for sizing it. And that's just the only way to go. Unless you can pull it out of the code book, you let the manufacturers size those. So after you get to an LVL, then you can get to PSLs, which is a, what is PSL? LVL stands for laminated veneer lumber. PSL is parallel strand lumber, which is like, well, it's, you know, well, let's see.
I remember in the codes course.
What?
I remember both of those from the codes course.
Yeah. So when you're talking about a parallel, I didn't want that. I wanted pictures. When you're talking about a parallel span truss, it's kind of like OSB. All right. So you're using strands but they're all parallel. So parallel strand laminated lumber, much like the LVL, where we had the, you know, all of the grain was running in the same direction. So in a parallel strand, it's like OSB. OSB, we're using chips that are oriented, you know, back and forth, but in a PSL, all those are going in the same direction and they're glued together. So they're not going to be as strong as the LVL, but they'll be cheaper because we don't have to have whole trees or big trees to get this set up. And in this case, we can take smaller trees and chip them up. And then we just, there's a machine that will orient all of these chips in the same direction. And they can be made out of smaller trees. And they actually, you know, if we're using plywood, these can be used, what's left over can be used as those strands as well.
Where's the PVL? Is that it? Where's that used mostly?
I don't know what a PVL is.
Was it PS? I forgot. What was the second one?
PSL, parallel.
PS.
It can be used in the same place as an LVL. It just will not span as long as an LVL. It's kind of like, it's like plywood and OSB. Okay. Plywood is better than OSB. OSB is cheaper because it uses, well, I don't know, these days it's outrageous either way. They can use smaller pieces of lumber, smaller trees, and the same process. Okay, so I've run out of time. Danny, did I miss anything that I need to go over on Wednesday?
Well, I think we covered a lot. I don't know if we've really missed anything. The only thing I was going to add about the web trusses and the eye joists was that just like lining up your studs, you really want to make sure that you've got your orientations correct on your joists, because some of them have those pre-established cutouts, the only places you can drill. And those web trusses, the truss joists, they, you know, if you got that space for your HVAC, you want to make sure you lined it all up correctly so
Absolutely.
the HVAC can run through it. And then you got to watch out for those hurricane clips because they'll cut the rest of your ductwork up.
Yeah, absolutely.